material that's being welded, and the weld part design. When we move to the next phase of setup, we have to adjust and align the tooling, and we have to make sure that the parts are manufactured consistently. Part-to-part variations, cavity-to-cavity variations can affect the setup. And then our input parameters, input welding parameters, such as, are we going to weld by a collapse? Are we going to weld by an energy, an RPN? And then we weld the parts, and we get an output. Typically, there's either a graph, weld process data, and then we can do our quality control on the welded part, a pull test, a leak test, whatever it might be, to determine whether that part meets our requirements. If it doesn't, then we have to sort of go back to our setup or our input weld parameters and turn those knobs, make those adjustments, pull those levers to determine what is the exact recipe in order to get the best part possible. And we're aided by this data and by this graph, and we'll get into this a little bit later, but the graph has a joining velocity curve. And that's really our key guidance in our navigation system, if you will, that tells us what to do or what to adjust. We typically look for a linear joining velocity, and we adjust, again, the weld parameters in order to influence that joining velocity curve.